Welcome to this channel, and I'm going to show you that you're going to enjoy the time you're going to spend, because look at this. When we're talking about X-ray, which is the major thing we are going to talk about here, when you look at this, what is happening? So the things happening here and many more are what we are going to say, and I'm going to explain this in the way you've never seen before, because we're going to talk about X-ray and the production of X-ray, talk about the nature of X-ray, and more, and the difference between X-ray and photoelectric effect or photoelectric emission. If you're very ready for this class, let's get started. Now let's start with the definition. We said that X-ray are produced when, there are a few points you're going to note here, are produced when rapidly, can I use black please? Okay, when rapidly moving, remember, rapidly moving electron that have been accelerated through a PD. Now, through a PD, please permit me to use this diagram, because you may think that the diagram is not the one you have seen in your textbook, but they may be different. But no matter what, they are all going to be explaining the same thing, that in a potential difference, you are going to have, in this X-ray, you're going to have that the X-ray are produced when rapidly moving electrons that have been accelerated through a PD of the order 1000. The potential difference should be 1000 or 1 million volts. When you have about 1,000 volts to, let's say, 1 million volts, when you have this between the poles, then you have an X-ray, and such that the electrons run to strike this place called the anode. Look at this place I'm marking. This is the anode, and this is the cathode, where the electron are moving. They boil off. So when they move from this part, they accelerate in that order. Look at this diagram. Now, when the electron, this is the cathode. Sorry, let me use the pen. So this is the cathode. When they move from here and they hit this target, and this target is sometimes called the anode, not sometimes called the anode. It's also the anode, can be called the target as well. Sometimes they say it's tungsten metal as this place, which is the anode, where the electron will hit. Then when they hit, something happens. Then the electron is now converted into a light. That light, which is represented by this yellow kind of thing, which is the X-ray in question. So, like I said before, X-ray, and inside this particular place where the X-ray is said to come from, is a kind of a glass or a tube that has a very low pressure. Please note the points I'm making. They have a very low pressure. Inside this tube has a very low pressure, and the potential difference between the cathode here and the anode is of the order 1,000 or 1 million volts. But the pressure inside here is as low as, let's say, 0.0000, which is the order. Let me just write the order. Let's say 10 raised to power -7 or less of the atmosphere. All right? When I talk about the atmosphere, I'm talking about the pressure inside this tube must be very low for us to say that we can have an X-ray. So X-ray production has to do with the explanations I've given you. But this experiment was conducted and produced in 18 in 1895, let me tidy up this screen a bit. Let me tidy up this part, okay, so I can have a better space to work with. Now, I said, no, okay, let's see. All right, come back here. Okay, so like I was saying, I said that in 1895, a man called, I don't know however you're going to pronounce this, because I know it's definitely not an English name, Wilhelm Röntgen, so this man in 1895 was the one that used an apparatus similar to thermionic emission, similar to this thermionic emission, because you know, when I was explaining this, when you look at this diagram, you may think, oh, it's the same thing as thermionic emission. So I'm telling you that the production of X-ray has the same principle as that of the thermionic emission. But like I said before, I'm going to explain a few things that are going to be different from the thermionic emission. And I also said that so that the electrons are buoyed off, electrons buoyed off, this one is going to explain better what I am saying. The electron is buoyed off from this place, which is the cathode, from a heated cathode, and are meant to accelerate and move towards the anode. This is the anode, by a large potential difference, by a very potential difference, and reduced pressure of the order which I have given you before, which is 10 raised to the power -7. So inside this place where this electron is moving, leaving the cathode, boil off as if somebody is pursuing it and moving in a very high speed to hit this target. This target is the stopper, where it's going to be stopped. What happened? When they hit it, something happens. Some electrons are absorbed as the heat energy, and some of them which were left are now converted to this yellow kind of thing you are seeing, which is the photon, and that photon is the X-ray. Because for me, in this case, I'm going to say that this X-ray is actually something that happens between electron converting itself to light. Remember, according to De Broglie, said life is all about symmetric in nature. If you have positive, you are going to definitely have negative. So, enough of all the story. And now the question should be, let's go back to the other place. Let's ask a very simple question. The question should be, why are we going to reduce the pressure inside this place, inside this space between this cathode and this anode, or the stopper? Why do we have the pressure reduced? I think I'm going to be answering you the question at the end. Please, if you know the answer to that, I would like you to hit the comment section and explain before the end of this video. Now, I also said that let's talk about the nature of this electron, the nature of the light which forms the X-ray. So what are going to be the nature? What is the nature of X-ray? All right. Now, we say that X-ray itself, remember, I'm done with the introduction of what is X-ray, and you have seen on the video how X-ray is produced and what causes it, and the conditions by which these X-rays are going to be produced. Now, the next thing we are talking about, the nature and, let's say, a kind of properties of X-ray. Now, I'm going to say that this X-ray, they are electromagnetic radiation. Electromagnetic radiation. And if they are truly electromagnetic radiation, that means they are going to have wavelength, they are going to have frequency. And if they have wavelength and frequency, and remember that these are electrons that were converted to this photon, which is the X-ray, that means they have mass. If they have mass, then I can boldly tell you that this equation is going to be used in talking about X-ray. This equation must be used when talking about X-ray. All right. Did I forget something? They must have speed. Very important. Sometimes they use C to demonstrate it. They must have a speed. Probably when we go into details, we are going to talk about maybe whether they are electromagnetic, they move in a straight line, they are cathode ray, blah, blah, blah. But there are important things I want to hit, and that is what I'm saying. They are electromagnetic. This formula can be applied in finding its wavelength, its frequency, and its speed, and the energy that they produce. So in that case, I want you to respectively be writing it this way. E for the X-ray, E is going to be Planck's constant multiplied by the frequency of that X-ray. All right, and I also want to say that the wavelength of this X-ray, which is called the lambda, can be measured by using crystal diffraction technique. Crystal diffraction technique. Okay, you can find what that is all about. You can use this to find the wavelength of that particular X-ray. Okay, so the question should be, and I want to say also that if you look at what is happening here, it's almost like that of a thermionic emission, and which is also photoelectric emission. Now that I mentioned photoelectric emission, we are going to ask ourselves, then what should be the difference between X-ray and photoelectric emission? All right, to answer that question, we are going to consider the processes that involve in the production of this X-ray and maybe a little of that photoelectric emission. However, that is not the essence of this video, but it's very important we understand truly what they are. Now, I want us to know that when we are talking about the production of X-ray, X-ray is transformed, remember, from this part, something hits this metal and then converts to light. Sorry, let me clean this part. All right, something converts to light. So that means I'm going to say that X-ray is transformed from kinetic energy of the electron, to the energy of the photon, You know what I mean by the photon? The photon is just the light, and that light is in form of the X-ray, which will just move out. The photon is just like this, which is also X-ray, because X-ray is light. It's one of the electromagnetic radiation. Okay, so, however, in X-ray, we neglect the work function. Why do we neglect work function? This is because this is the target. Remember, I told you this is the target. And the initial energy of the void of electron, because they are small in comparison to other energy. See, I say in X-ray, we neglect the work function of the target and initial energy of the void of electron. So, work function of these parts and initial energy of the electron that left. And we neglect initial energy of the void of electron because they are very small in comparison to other energy. Now, when we talk about work function, we are talking about the minimum energy required to liberate an electron from the metal surface. The smallest energy needed to liberate an electron from the metal surface. So, whenever we are talking about X-ray, we are going to be neglecting this work function. All right? We are going to be neglecting the work function. So let's talk a little more of what happens when electron hit the target, which is the anode, they are stopped from moving further. You know, when they come from here and hit this target, they are stopped from moving further. However, the energy is lost in the process. I think I've explained this. Some energy we are lost, while the rest of the energy we are used in the production of the photon. And there are a few more equations. What is this one? Okay. There are a few more equations we are going to be using. We can also say that this E, which is the X-ray, is equal to EV. I'm going to say EVS, whereby VS is the voltage of this one, which is the target, which is called the stopping voltage. We can use that in place of calculation. We can use this as the stopping voltage. And you know, since it is the movement of electron, we should also include the fact that when we are talking about X-ray, we should also consider this, because of course the Broglie equation. So these are few more equations we can use whenever we are talking about X-ray. All right, I think this should be where we are going to draw the curtain on this aspect of X-ray. Thank you for being part of this lesson. Remember to hit the subscribe button, like this video, and share it. Have a good time.